Welcome to DPS Education. In this video, we are going to learn about mesh analysis. Mesh is a closed loop in an electrical network which doesn't contain any other loop inside it. So here why we are finding mesh analysis. So the main aim in an electrical network is to find the power delivered or power absorbed by a different electrical element. To calculate the power, we need two elements, that is voltage and current. Here we are using mesh analysis to calculate the unknown current in the given circuit. If you find the current and the voltage, easily we can find the power delivered or the power absorbed in an electrical element. So there are some few steps to find the mesh analysis and like to find the unknown current. So the first step is to identify the number of loops. So now let us consider one example. So let us consider this circuit. In this circuit, we have to identify the number of loops. So here this is a closed loop and this is a closed loop. So the number of loops is 2. There are 2 loops. So now what is the second step is assigning the loop current. Here we have 2 loops. For these 2 loops we have to assign the loop currents. So here we are using like current I1. For this we are assigning current I2, and this current, the direction and the flow of current, the direction of flow of current, even we can take in clockwise direction or anti-clockwise direction, but for our convenience we are taking it in clockwise direction. This is direction of current. And now the third step is applying the KVL for the each loop. So let us consider this. Here we will give plus minus, and here assign the symbols plus minus plus minus. Here here one thing we have to observe, that is important thing, is here the current is flowing downwards. If we consider from this loop, the current is flowing like upwards. So the net current will be I1 minus I2 or I2 minus I1. This is the net current here. So now we'll apply the KVL for the first loop, that is minus to plus 10 plus to minus 2 I1 minus 3. So here since we are applying for the loop 1 and we have assigned the current as I1, we will take it as I1 minus I2. Here we consider that I1 is greater than I2, so we will take net current as I1 minus I2, that is I1 minus I2 is equal to 0, that is 10 minus 2 I1 minus 3 I1 plus 3 I2 is equal to 0, that is 10 minus 5 I1 plus 3 I2 is equal to 0. 5 times of I1 minus 3 I2 is equal to 10. Let's consider this as equation number 1. Now we'll apply KVL for the second loop. Here while applying KVL for the second loop, we'll take the direction as plus minus, and since we are applying for loop 2, here we have assigned the current as I2. When we consider this loop, the I2 is greater than I1, so we'll take net current as I2 minus I1 while we apply KVL for the second loop, that is minus 3 times of I2 minus I1 minus 4 times of I2, and this is plus, this is minus, minus 15 is equal to 0. That is minus 3I2 plus 3I1 minus 4I2 minus 15 is equal to 0. 3I1 minus 7I2 is equal to 15. This is considered as equation number 2. Here we have obtained two equations. So the last step, that is fourth step, is to solve the equations. Here if we solve these two equations, we'll get I1 as 0.96 amps and I2 as minus 1.73 amps. By this we have found the unknown current I1 and I2. If we have three loops like this, then we'll assign the current as I1, I2 and I3 for each loop, and we'll follow the same procedure if we have three loops. Thank you.